Alright, today we're going to talk about 11.1 polynomial functions and polynomials. But first, let's talk about their roots and zeros. If you notice right here, it states that if a number n is a solution of a polynomial equation, p of x equals 0, then n is called the root of the equation. If a number n, when substituted for x, makes a polynomial function p of x equal to 0, then n is called a zero of the function. There's some subtle differences, but really what it's saying is that a root and a zero are the same thing. If you plug in n for x, or if you solve an equation and you find the values of x when p of x is equal to 0, then that value that they're calling n is a root or a zero. Okay, so now we've talked about the definitions of a root and the definition of a zero, and know that basically they're the same thing. If I ask you for the root of a polynomial or the zero of a polynomial, I'm asking you for when p of x equals 0, what are the values of x? So, I'm going to start off with example 1. Okay, example 1 states we want to determine whether given numbers, so determine whether the given numbers are roots of p of x equal to x cubed minus 5x squared plus x minus 5. Okay, so when I'm saying that is, what I'm basically saying is, what are the values, actually that's not what I'm saying. What I'm saying, pardon me, so you determine whether the given numbers of the roots are roots of p of x equals to x cubed minus 5x squared plus x minus 5. What you're trying to do is you're trying to determine is, do these values make p of x equal to 0? Okay, that is the question you're asking. And if I could spell values, that would be helpful. There's your joke. Okay, so let's start with A. A says -5. Okay, so what I'm going to do is I'm going to take p of -5, and I'm just going to plug in -5 for all the x values. It's -5 cubed minus 5 times -5 squared plus -5 minus 5. Well, that gives me -125 minus, well, that's 5 times 25, so that's minus 125 minus 5 minus 5, which, if you notice, end up being -260. So, no, -5 is not a root. Okay, so then we go to part B, and we just do the same thing. B says -I. And just because it says I there doesn't mean we can't still use it or do it. We know how to deal with it, I. So we'll do -I, which is, so then we do -I cubed minus 5 times -I squared plus 5 times -I minus 5. Okay, well, I cubed, I remember from a while back that I cubed is -I. So really, this is like saying -1 cubed and I cubed. So that's, well, if you remember, I squared is negative 1, so this is really like saying negative 1 squared, 5 times negative 1 squared times I squared. And that's just saying minus 5I minus 5. Oh, there's no 5 on that. That's just no 5 there. I apologize. There should not be a 5 there. Okay, so then negative I cubed is negative 1, and I cubed is negative I, so this just becomes I. I squared is negative 1, that becomes positive 1, so 5 times negative 1, negative 5 times negative 1 is plus 5, that's minus I minus 5, that equals 0. Therefore, P of negative, or we can say that negative I is a root. Alright, for example 2, it says determine whether the given values are zeros of P of x equals x cubed minus 3x squared plus x minus 3. Now, the other one asks for roots, this one asks for zeros. You're going to do the exact same thing. All you're doing is plugging in for x. So we start with A, and A has 3, so we're going to plug in 3 first. So I do P of 3 equals, that's 3 cubed minus 3 times 3 squared plus 3 minus 3. Okay, we get right here, well, that becomes 27 minus 3 squared is 9 times 3 is 27 plus 3 minus 3, well, that equals 0, and therefore we could say that 3 is a 0 of P of x. Okay, and then part B. Okay. Part B is asking about 2i. Okay, so we'll do P of 2i. That's going to equal 2i cubed minus 3 times 2i squared plus 2i minus 3. Okay, well, we look right here. 2 cubed is 8 and I cubed is negative I, so that's negative 8i minus 3. 2 squared is 4. I squared is negative 1, so it's negative 4. Let's make that negative more prominent. So it'll be negative 4 plus 2i minus 3. Okay, and then I just combine like terms. That and that become negative 6i. That's plus 12 minus 3, so that's plus 9. And since 2i is not a 0 of P of x, that's because it did not equal 0. And that's how you determine roots and zeros of polynomials in chapter 11.1.